Hi, you're listening to Brendan Davey, and today I'm going to be talking about my Aurora forecast app or service. So the application's available from my website, brendandaveyphotography.com, and it's available under the Aurora Services tab. As you can see here, the forecast service. It's worth noting that once you open this in a browser, you can home screen the application on your mobile device, so either an iOS device or an Android device, and then it will appear as an icon on your home screen. And then every time that you run it from there on in the future, you don't have to have the Safari navigation bars, which is quite handy. So to open the application or the service, all we need to do is just initially go to the Services tab and then click on the Service Forecast or the Forecast Service, and then you will be taken to the site here. And as you can see, it's optimized for mobile devices, so it looks a little bit strange when you view it in a normal desktop browser. The buttons are quite big and the interface is quite chunky. You'll also notice that it's configured to be white text on black, and most of the button or most of the interface where possible is red. The reason for this is that it causes the throws out the least light of a night when you're using it, when you want to view it and you've got your camera running, or there's others around you that may have a camera that you could be exposing too much light to the scene. So we can see here, this is loaded up with the defaults. Now, there's a number of data sources that are used to create the chart here. Most of the data comes from the ACE spacecraft, which is about 1.5 million kilometers from Earth, and it's also supplemented with some local data from the GOES satellites, as well as some data that NOAA puts out, some estimates based on the POSE satellites, which we'll get onto a little bit later. So the charts basically consists of three sections. You've got the section here up until the blue bar, which is the data that has been, or the data received that at the ACE spacecraft has arrived and been. It's now in the past. You've got the small blue bar here, which is a rough estimate as to currently what's arriving at the Earth. And then you've got the forecast section to the right of that bar. So this is showing what's coming up, or and you can see the time down the bottom here of when it will be occurring. So what we want to be looking for is we want to be looking for events that occur in this section, and sort of looking at the time to know when they occur. And by events I mean looking at the data and knowing, based on the data, if there is a likelihood to see an aurora or particularly some beams. So one of the factors that will give us an aurora, although not certain, is the BZ value, which is the red line on the graph. Now, generally speaking, whenever the BZ goes into the negative territory, there is a greater chance of an aurora, although it is slightly dependent upon how fast the solar wind speed is. And we'll get on to adding that to the chart later, and you'll be able to see that. Looking at this current chart here, we could probably say that maybe here, when the BZ drops to approximately -4, there is a chance that the aurora will become active, or if there is an aurora, that the beams will become more active. And based on that, you could probably see the time would be around 10:20-ish. So if we refresh the chart, we'll actually see that it is slowly moving towards the blue bar, which is what's occurring now on Earth. So the blue line here on the chart is the BT value, and that's the magnetic vector, or the maximum magnetic vector currently recorded at the ACE spacecraft. So the BZ value cannot get any greater than the blue value, so whether it be negative or positive. So if it's currently plus around +6, the BZ value cannot be greater than +6 or greater than -6 down here. So that can give you an indication as to how much the BZ value is likely to swing, because this value normally stays fairly steady, as you can see. So if it's been fairly steady at 6 for the last 3 or 4 hours, then it's unlikely that it's going to, well, it's impossible that it will be able to swing greater than -6 unless it starts going up itself. So the additional information on the chart you'll see is the grey line, which is the data, the magnetic data from the GOES satellite. Now that's a satellite that's in geostationary orbit about 38 kilometres up. So this data can't really be plotted in real time. It has to be added to the chart as information that has been. So it's very, very close to now, but not quite. It's probably, at best a minute old. The reason why I've plotted this is because this information, the red information, as you're aware, takes about an hour to arrive at Earth. The grey information, or the current data, is next to real time. So what we can do is look for correlations between the two lines. So for example, here where the BZ's dropped, and we also notice that it correlates to roughly a drop in the local magnetic activity at the same time, or when it was due to arrive, we can say that there's a fairly strong link between the two, and that the arrival time is roughly accurate. So if you're looking at this value and you're noticing that it's sort of matching the BZ, or it's fluctuating quite wildly, then you can be fairly certain that there are strong magnetic sort of fields at play, or that the BZ value that was due to arrive has arrived, or is fairly accurate. The green lines on the graph are the NOAA estimate, or the NOAA numbers that they put out. So 1 through to 10, the power rating of the solar winds being transferred into the northern and southern hemisphere. So if you look on the chart here, it says, for example, the first one says NOAA POES estimate, and it's got S for south, meaning this is over the South Pole, and it's got a value of 43 gigawatts, which is a level 8. So these values can be used to give you an idea of how strong the solar winds, or the events arriving from the sun are, or how they're impacting on the northern and southern hemisphere. They were always plotted into the chart in the past, because it takes NOAA normally at least an hour to produce the values. So the satellite has to do a full orbit. So it's the post satellite, which is about I think 270, 280 kilometres above the Earth. After it's done a full orbit, NOAA take all the data and they produce an estimate. So moving into the customize section, this is where we can add additional fields or modify what's currently visible on the chart. Now you can change the range of the graph, so if you wanted to see a larger time period, so if you wanted to look at the last 12 hours to get an idea of what's been happening in the last 12 hours, you can increase it, and you can see here we've got a much larger range. This can be useful if you want to look at more of the POES values to get an idea of how it's been going over the last, say in this sample 12 hours. And we can see here that the brighter greens are where it's the strongest, so you can see it became quite active around this area, and then was quite a lot lower during this period. We can also look for greater trends, like how the BT is trending, or how the BZ's been behaving over the last 12 hours. So the default is normally 4 hours view though. So we can see here now there's some new POES data that's just arrived, and you can see it's approximately an hour and a half old. Unfortunately, there's no way to get around that. It's just the nature of the data. So additional data sources that we can add to the chart, we can add any of the other magnetic vectors from the A satellite. So BZ's not visible here because BZ is always plotted on the chart. So let's have a look at the solar wind speed, and this is another good indicator as well. So the solar wind speed here shown in green, currently hovering at around 400, is also an indicator of the likelihood of seeing an aurora. So the stronger the solar wind speed, the less, generally speaking, the BZ has to drop for you to see something. So at around 400 kilometers per second, values of probably around -4, -5 in the BZ would be enough to generally see something. This can also be used as well, so that if you have a very, very strong drop in the BZ, and there is also at the same time a very, very strong rise in the solar wind speed, then it really shows quite a strong impact at the A spacecraft, and that's also another good indicator. So if you see something, coming up where the BZ's dropped and the solar wind speed has risen, then keep an eye on that. Another thing to look for as well is the proton density. So this is how dense is the solar winds that are arriving. Again, we're looking for similar characteristics to the solar wind speed. So if the BZ's dropping or has dropped, then a rise in proton density at the same time is a good indicator as well. So we can see here at the moment it's hovering around 6 to 8, which is an okay number to see in Aurora. If we get into sort of values between 10 and 100, then there's a pretty strong chance that we'll see something if the BZ is correct and we've got decent solar winds. So additional to the GOES 15 local satellite, we also have GOES 13. So these operate in a pair. They're normally called east and west. So one operates on one side of the Earth and the other operates on the other side of the Earth. They're not quite opposed, but they're very, very close, and they can give us an idea of a better idea of what's going on if we plot both. So if we see a strong movement, for example, here, and then there was a similarly strong movement, we know that something is hitting the Earth, and it's fairly consistent right across the globe because we've got two satellites on opposite sides of the Earth that are detecting the same thing. So you can see here that some of the anomalies, for example, do appear to be roughly occurring on both. I find though that just having GOES 15 is enough to determine that. It leaves a little bit less clutter on the chart. So again, if we want to remove the NOAA estimate, we can remove it, and you can see the green bars are gone. I normally leave them there. They're quite handy just to get a bit of an idea of what's been going on. And you can also adjust when it should be visible on the chart. So for example, if you only want to see values of greater than 6 plotted, then we leave it at 6, or we could just say, well, I want to see everything. So anything 1 or greater, can you please show me? And then you'll see here that you'll start to get more, particularly if we go back and we say, we want to look at the last 12 hours. We've suddenly got a lot more than we did before. So I'll put that back to 6. Depending on where you are as well, you can change it so that the chart will plot in your local time. So for example, if you wanted to view it in the UTC time, then you can do that. You can now see that the time's changed along the bottom of the graph, and it's now showing in UTC. So another useful feature is we may want to look at a period in the past as opposed to what's going on now. So we can do that by just clicking in here and then selecting the day we want to look at. So for example, we may want to look at the 18th because I know something occurred on the 18th at around 10 o'clock. Now it's useful to keep in mind that the time here is in UTC. So 10 o'clock that I'm placing here is 10 o'clock in the morning UTC, which is roughly 11 o'clock at night Australian time. So we can see here we're looking at what occurred roughly on the 18th. So this particular evening there was actually some activity going on, and this is why I've brought up this period because it's quite useful. You'll notice that because we're looking at a day in the past, there is no forecast line, no forecast box, there's no now box because it's all irrelevant. But you will notice that the current GOES data we have offset against the BZ data, which is why it doesn't continue on. So essentially what we've done is we've taken that and we've shifted it so that it matches the BZ values arriving to give you to be able to look for indicators. So looking back at this data, first thing we notice is that the GOES was fluctuating quite wildly, which is a really good indicator. And we also look at the BZ and we'll notice that there were quite a number of drops, particularly during this period here. And this period here was quite active. And you'll notice that when the BZ dropped, there was also quite a significant drop in the GOES 15 data as well, the magnetic field recorded at GOES. And here again, it dropped quite significantly, and there was also a correlation. So you will also notice on this particular chart at this time that there's been a few additional bars or comment bars added to the data. So what's happened here is someone's out in the field has actually reported an aurora. So they've reported seeing some beams. So we can see here small beams starting, and that was in Tasmania. And then similarly here we've got a comment, huge beams, very big, Evandale, Tasmania. So these are placed in real time out in the field, and they're quite good because they show strong correlations, or they can show on the chart, both in next to real time and looking back in on previous days, what caused them. So we can see quite clearly here that the huge beams were caused by that BZ drop arriving at Earth, which was backed up by the GOES data. If we just click refresh, it'll take us back to now. So to give you an idea of how that works in real time, under the report tab, I can submit a report. So for example, I'll just put test first so everyone knows that it's a test. And then I need to also let everyone know approximately where I am. So I'll just say that it's in Hobart, Tasmania. So we submit that report. I get a comment back saying that the request to add the comment has been done. It gives me a time of when it was done. It's worth noting that there's no point coming back to this after the fact and then putting the information in, because it timestamps it at the current time. So it really needs to be placed into or submitted at the time you're seeing the event. So if I now refresh the chart, we can see here in real time there's been a comment added in it. So this can be quite handy for people if they're sitting at home and they're viewing the chart and people are submitting comments. They can get to see what activity is happening out in the field. So as far as the options that I find the most useful, this is currently how I have mine configured, and I find the most useful is I view a fairly small period of time, 2 maybe 3 hours. I have the solar wind speed turned on because that's quite handy to be able to see its correlation to BZ, and I also leave the GOES 15 data on. So this is normally enough for me to be able to predict or tell when an event's going to occur. And it's just a matter of waiting until where you see a perceived event arriving at Earth, and then having your camera ready. So have fun catching your auroras, and hopefully this will be useful for you.